Our current conversation about artificial intelligence is bogged down in surface-level mechanics. We argue over plagiarism, we worry about deepfakes, and we marvel at how fast these systems are churning out text. Obsessing over the final product blinds us to the divide between machine and human mind. To navigate this landscape, we need to look past technical arguments and find a philosophical compass. Understanding AI requires examining the one operational trait biological brains and digital algorithms share: prediction. In 2005, Jeff Hawkins proposed a theory of intelligence that redefined the human neocortex. He described it as a biological machine built for relentless anticipation. The brain builds a working model of the physical world. Reaching for a coffee cup requires predicting muscle tension, the texture of ceramic, and the exact heat of the liquid, all calculated fractions of a second before the action occurs. When sensory reality clashes with that internal prediction, the brain experiences an error. Thinking is the process of adjusting the model to fix that mismatch in real time. AI also functions as an error-correcting engine. Therefore, the way to understand the tool is to identify the specific types of errors it is trying to minimize. A large language model operates on a backward-looking timeline. It scans its training data to construct a forward path of text, one token at a time. This chart shows the system's core mission: minimizing statistical error by finding the mathematically most likely next word. This checking occurs entirely within a closed loop of historical text. The AI exists in a vacuum, isolated from physical and social reality. Hallucinations occur when the system successfully generates a probable sequence of syntax that lacks grounding in empirical truth. Intelligence optimized solely for textual probability remains blind to physical and emotional reality. Human biological wetware evolved to minimize systemic real-world errors. Our survival depends on predicting consequences beyond the immediate input. An AI can generate a flawless circuit diagram. Only a human engineer can simulate how that design will physically fail in sub-zero temperatures. Ethical consequences follow the same logic. An algorithm can draft a brilliant policy memo, but only a human leader can predict the damage to team morale or the political fallout of its delivery. This is humanics. It is the ability to assess the second and third-order ripple effects of an action. Survival requires seeing past the immediate output to the systemic result. You can find this gap in the sci-fi archetype of the logical machine, characters like Sheldon Cooper or Commander Data. These characters possess massive retrieval speeds and perfect syntactic logic. They predict the next token flawlessly. Their recurring flaw is the correct statement that ruins a social situation. They calculate probability while ignoring the social consequence. They require an essential human layer, the penny or the kirk, to filter raw logic through empathy and context. Technical precision remains a simulation until a human mind audits the output for its real-world impact. Accepting the consequence gap requires a shift in how we train and test human intelligence. AI has automated the bottom tiers of Bloom's taxonomy. It now owns the foundational tasks of knowledge retrieval and comprehension. We must move up the ladder, shifting our role from generating raw material to inhabiting the tiers of evaluation and synthesis. The new standard for human work is the wicked problem: complex, ill-defined scenarios where the right answer depends on which consequences you choose to prioritize. The ability to generate a plan has become a baseline commodity. Value now shifts to the ability to evaluate exactly where that plan will fail. This creates a new workflow. We treat the AI as a probability partner, using it to establish the baseline statistical solution. Then the human audit begins. We feed hypothetical ripple effects back into the system, overriding logic based on ethical and physical constraints. In this landscape, AI is the current of a massive river. It is relentless, powerful, and statistically precise, yet fundamentally blind to its final destination. We cannot outrun the speed of the current. We must use its power to move, while remaining the only navigators capable of seeing the waterfall ahead.